This little video is about writing formulae, simple ones and the more complex ones, and it's really for years 11 and 12. Let's take a look at how you would write a formula. You'll be given the name, for example, magnesium chloride, and you'll be expected to write the formula for that. In order to write the formula for magnesium chloride, there are two things that you need. You need to have both the symbols and the charges belonging to that magnesium chloride, okay? So your best friend here is going to be the periodic table, and I've got one in front of me, okay? Your periodic table at GCSE will look like this, but I've added a few things to it. The first things I've added are the charges. You can see at the top of group 1, I've got +1. At the top of group 2, I've got +2. Then going all the way across to group 3, +3, then plus and -4, then -3, -2, -1, and 0. You guys need to be able to remember how to do that on your periodic table when you go into the exam. Those are the charges that belong to the substances in those groups. And if you've got any clue about ions and ionic bonding, you'll know that those are the ions that those substances make when they bond as well. This group in the middle is a bit different because actually these substances can form different types of ions when they bond. So we don't just get one number that goes with these. In fact, iron can have several numbers when it comes to its ions. And you can see that I've written them in Roman numerals here, 2 or 3. Zinc, I've only just written 2 for. Okay, if you can see it's over here. Because zinc usually forms an ion of +2. If you're not too good on Roman numerals, then I have listed them here for you. All right, you should be able to see that number 1 is like that, number 2, number 3, number 4, number 5, number 6. Usually you're only using the first couple of Roman numerals there, okay? So let's get back to our example. I'm going to start with a simple formula first. Magnesium chloride, it's just made from 2 elements, magnesium and chlorine. So the first thing you do is find the formula for each one, or the chemical symbol for each one. And what you should be able to see over here is magnesium is Mg. So I'm going to note that down underneath. Camera's a wee bit blurry. Let's clean it up a bit. Okay, and the formula for chlorine, which is what chloride comes from, is over here. Cl. And then we're going to put our charges in. Magnesium is in group 2, and up at the top I've written the charge +2. I'm going to write that underneath. Chlorine is over here in group 7, and you can see up at the top of the group it's -1. So I'm going to add that in as well. Once you've gotten to that stage, you follow the same little trick every time, and it goes like this. You swap the numbers over, and then even though you've put the charge down, you're going to completely ignore it. Don't worry about why you do that. You don't need to know. All you need to know is that you do it. Okay, so we're going to swap the numbers. We're going to give chlorine's 1 to magnesium. We're going to give magnesium's 2 over to chlorine. And what that tells us is in the formula, there's 1 magnesium atom and 2 chlorine atoms. So the formula is Mg1, which you can just leave off, Cl2. All right, make sure that your little numbers are subscript and that they're small, okay? Let's try a more complex one. Let's try sodium sulfate. This time, you can look for the sodium just as we did before. Sodium's over here in group 1. Symbol Na, charge +1. Okay, but sulfate doesn't come from an element, it doesn't come from sulfur. If it was just sulfur, the formula would be, or the name would be sodium sulfide. So what you need to do this time is you need to go to your little data leaflet, which is on the back of your periodic table, and find sulfate that way. Here's sulfate. You'll see it's SO4 and then 2 minus. The SO4 is the formula, and the 2 minus is the charge that goes with that. Okay. So, back to our little example. sulfate, SO4 is the formula, and the 2 minus is the charge. In the same way as we did before, swap it over. That tells us you've got 2 sodiums in your formula and 1 sulfate. So you're going to multiply the whole of the sulfate by 1. And your formula is Na2SO4. Okay, we'll do another wee one as well. I'm just going to clean that camera down. Okay, we'll do another. Let's go for iron hydroxide. Alright, now, if I look for iron, it's one of those funny ones there. Okay, and iron doesn't have a number assigned to it because it isn't in a specific group. So in the question, they should tell you which iron to use. They might tell you it's iron 2, or they might tell you it's iron 3. I'm going to use iron 3 in this case, iron 3 hydroxide. We know from a moment ago, looking at the periodic table, the symbol for iron is Fe. We've been told that the number is 3. Hydroxide is from the data sheet, and we should find hydroxide here. OH with a minus. So it's OH, and your charge is -1. You're going to swap the numbers. You have 1 iron, and you're going to multiply the entire hydroxide by 3. So the way that you do that is Fe1, which you don't need to include, and then so that you're multiplying all of the hydroxide by 3, we're going to put it in brackets and put a little 3 at the bottom. Okay, you follow that pattern every time, don't skip any steps. You've got to do that each time so that you make sure your formula is right. There are some formulae that you need to know off by heart. Those are the formula of the acids: hydrochloric, sulfuric, nitric. If you're in year 11 and 12, more year 12, you need to learn ethanoic acid as well. You need to know that when you're writing molecules on their own, like oxygen, whenever it's on its own, it's a diatomic molecule, O2. Nitrogen's the same, hydrogen is the same, all of the halogens or halogens are the same. You write those all, when they're by themselves, you write them as diatomic molecules. And the other ones that you need to know about are the other covalent molecules from your bonding work in year 11. That would be methane, ammonia, carbon dioxide, and water. Those are all I can think of just off the top of my head, okay? And you need to learn those formulae off by heart. Any other formula you're given, whether it be for a salt or a carbonate or whatever, you use this little technique.